Yeah, thank you. My name is Ronald Leeper. I work for NC State. I'm also a PhD student going to NC State, so get to do a little bit of dual roles here. Really like the order that Elise has put us in. So someone's described drought monitor. Nathan's talked a little bit about the Upper Missouri River Basin, and we're going to be talking about some of the drought monitoring tools we're trying to develop using the UMRB data set. So I'm kind of in a conference where everybody knows a little bit about soil moisture, so I don't need to get in too much into how soil moisture is a direct measure of agricultural drought. But I think the last talk really talked about this. When you start trying to use the data, you really have to put the soil moisture observations into some sort of context. Typically, this is done using a historical record, like 30 years of data. If you use some really interesting, cool statistical sampling techniques, you can estimate the 50th percentile with 5 to 7 years of data. But the Upper Missouri River Basin is unique in the fact that it's deploying right now, and we're trying to use the data right now to help understand what's going on across the Upper Missouri River Basin. If you didn't already know or see some of the plots, I have a map of that and where those stations are. And where we want to see if we can help monitor drought across this region with less than 2 years of data. So we can't really put it into any sort of percentiles or any sort of historical context, but we do have information about the soils that the sensors are placed within. And so this is what I call loosely a soil context. So if we know the types of soils that we're placing the sensors in, we can get information about the metadata of the soils, which I think a couple of talks have already talked about how important that is. And we can begin to extract out wilting point and fill capacity. What we've done for the UMRB, because some of the stations are so new, we don't actually have lab results yet. I'm happy to hear Synoptic has some of that data in their API now. We haven't really used it yet, but that's probably something we should do at some point. But we leverage the we leverage the USDA's GNATSCO database to extract out percentages of sand, silt, and clay for our stations. This allows us to build a water retention curve using the Rosetta version 3 model. I'm kind of going through this real quick. And we can build a water retention curve like you're seeing on the graph behind me. And for certain thresholds of matrix potential, we can extract out wilting point, which is kind of the lower end of plant available water, and fill capacity, that's the upper end. So that kind of gives you the full range of water available to plants. And from that, we can put together a couple of metrics. So the ones that we're going to talk about in this presentation are fractional available water. So for this, we're using wilting point and field capacity to see how much water we have available to plants currently observed, divided by the full range. So the difference between wilting point and field capacity. And this gives us a ratio. This is often expressed as a fraction, 0 to 1. For our products that we're putting online, we're making it a little easier to interpret. We're putting it into percentiles. So as your fall approaches wilting point, you're going to hit 0% as you approach field capacity at 100. And then the other one I want to talk about is categorized soil moisture. So this is a little different than fall. It's kind of, it's really built on the premise of some of the earlier USDA data sets looking at crop. I think it's crop preparedness, but basically they go out and they survey the top soil layer. They kind of just grab the soil and squeeze it. And based on how much it clumps or falls out of your hand, they put it into these broad categories of very short, adequate, and surplus. And I see some of my T's are missing on short. Okay, it's actually rolling down. I see it now. I thought I misspelled short. Anyways, so with those values, you can take fall values, which gives you a very specific 0.2 or 20%, or you could say, am I in a water limited environment? So this is combining your very short and short categories, or am I in a non-lump water limiting environment? So different ways to look at the data. And if you do have some of these broader classifications like water limited conditions, it may be more broadly representative across space. So in order to distinguish short and adequate, we have to pull out additional threshold. This is critical theta. And so theoretically, this is the soil moisture value. We're going to get some of the soil physics here. But as you get drier from critical theta, any reductions in soil moisture limits ET. So what I would loosely call the definition of agricultural drought when you hit CT. Okay, so we developed all these products for the Upper Missouri River Basin, and we actually had a drought that kind of moved through the region in that I think it was in the summer of 2024 it began, and this provided us an opportunity to use this drought as a case study to evaluate how these metrics are doing with respect to the drought monitor. So that's kind of what this talk is going to focus on. So we took the US drought monitor conditions, we had station lat longs, we extracted the values out, we were able to define drought events, much like the schematic here behind me. And so drought monitor ranges from none to D4. D4 is the most severe category, and we're defining drought onset as the first week you hit D1. So that's where you get the orange bar, the first orange bar. And then it goes all the way until you have your last week of D1 followed by 3 weeks of no drought. So that kind of defines your onset and your termination periods. And then if we really want to dig down deep, which is kind of necessary to understand and understand some of the results we're going to share, we parse the drought event into these phases. Onset phase, which is first week of D1 to your maximum value. So if it was D4 for a drought event, in this case, it's D3. It's the first week you hit D3. And then your main phase is that time between your first peak to your last peak USDM condition. I promise this will all help later. It's kind of a complex description. So the first thing we did, we just said, well, how does fractional available water vary with the drought monitor? So we have a histogram of our top layer fall. So this is combining 5 and 10 centimeter or 2 and 4 inch, depending on which depending on which system you prefer. And one of the interesting things that kind of jumped out to me is that for D1, D2, and D3, D4 categories, we have a bimodal response. So we see we have very low values of fractional available water below 0. We have a peak, and then also above 0, we have a peak. So we're seeing for the same drought monitor category, both wet and dry fractional available water conditions. And this is also the case for T3, D4. This wasn't as severe or noticeable for the subsoil layer. So it's a slightly different perspective there. So to look into this a little bit more, we built a time series of fractional available water across the UMRB. So we're averaging over all the stations. And in order to do this, because some stations start at drought at different times, if you notice the 0, if you squint your eyes, you might be able to see the 0. That's the first week of drought onset. So we organized all the stations by time of onset. So all the negative values before 0, that's what fall's doing before drought onset, and everything after is what fall's doing after drought began. And one of the things you note is we see declines in fractional available water prior to drought onset. After drought onset, they kind of level out, and then we even begin to see recovery in the fractional available water as drought continues. So we did an average across the network. You're like, well, maybe that's just an average. How does this look like at individual stations? So I kind of have some anecdotal cases here for those. For the AVNW4, I don't know what station that is. I should have pulled that out. But if you ask me later, I'll look it up. But basically, we have drought monitor categories we can show on this graph, and we see drought onset. Looks like in mid-July, but we're seeing the dry down in soil moisture before onset. And then after the winter season, so when the soils freeze, we're not able to compute some of these metrics, so that's why there's gaps in fractional available water. But on the other end of the frozen period, we see fall has recovered. It's above 0.5, so pretty good conditions, but we're still in a D1 status. So there's lingering drought that the drought monitor continues to report, even though the soils have recovered. This is another station, so it's showing a slightly different pattern. I'm not going to get into it to save time, but you kind of see a drawdown before, but maybe not as large of a head start. So the drought monitor is more in line with this station. So this is where the drought phases come in. So the idea from what we're seeing in the bimodal distribution is that the drought monitor doesn't distinguish between D1 going into drought and D1 ameliorating. And so when we broke the drought down by these different phases, and we looked at how fractional available water varied within the different phases, I added 2 more because I'm a geek, I guess, a nerd. But I wanted to look at what this fractional available water was doing 6 weeks prior to onset. So that's what that pre-drought. And then I have a post-drought, which is 6 weeks after the drought ended. And what we see with fractional available water is even before drought onset, we're getting a dry signal. So most of the observations, that 50th percentile is very near wilting point, and we have a lot of values below that. At onset, we have most of the distribution below 0, indicating we're below permanent wilting point. And the main phase was interesting. We would expect this this would be the time where the drought monitor is going to have its most severe categories. So D3, D4s, you're going to see more of those. And we actually have a broadening. We actually have both wet and dry conditions. And then as the drought recovers during this amelioration phase, so we're going from the highest category to drought ending, we see the wettest values of fractional little water. So you can imagine you can still have a D1 drought category, and your fall is going to look like this, really high, and you're going to have a D1 category somewhere over here on onset, very low. And that's why we see that bimodal distribution. So in some ways, maybe the soil moisture values can add context to what the drought monitor is reporting. I'm kind of getting ahead of myself. So one of the last things I wanted to show before we kind of get into some of the summaries here, but we wanted to show some of the results from the categorized soil moisture. We're still trying to figure out what's the best way to aggregate this information and show it. So what I've done for this talk is I took all the conditions of very short, adequate, and surplus, and I looked at the fraction of time they appear within pre-drought. So for each of these different drought phases, if you stacked all these bars together, they're going to sum to 100%. So the main takeaway from this graphic is for the water limited conditions. So this is if you stack the short and very short on top of each other. For pre-drought, you're looking at about 70 to 80% of all the observations in pre-drought for this particular drought event. The stations had water limited conditions. When we get to onset, it's even higher. It's about 80 to 90%. This again alleviates a little bit because you see adequate kind of bump up in the main phase. So I think what's happening in the main phase is you can have rain events within the drought. It doesn't end the drought event, but it does wet the soils, and we see that in the particularly in the topsoil. In the amelioration phase and in the post-drought phase, we see that the most dominant observations are adequate and surplus. So that's just kind of our first pass at using some of the categorical data. And I'm really interested if anyone has any ideas on how to expand this further. This is showing the same thing for subsoil. Subsoil responds a little bit differently, but overall same pattern. Post or pre-drought onset in the main, you have more of your observations are in the water limited regime. Okay, so to summarize, I kind of threw a lot at you. We were able to put some products together with less than 2 years of data and actually correlate well with the drought monitor, although we did see differences. We saw that the soil moisture dried down before onset. We also saw recovery in the soil moisture before amelioration, before the drought monitor ameliorated. So the soil moisture is kind of a leading indicator of the drought monitor, if you want to look at it that way. One of the interesting things that I'll note is that fall tended to get below wilting point, maybe a little more frequently than we would be comfortable with. And so we're still looking at what's the best way to handle that. And this was also the case for field capacity as well. But one of the things that I'm really interested in is trying to understand and wrap my head a little bit more around for the same drought category, you get different values of fall. And again, I think that's because the drought monitor is trying to encompass all drought, not just the agricultural or soil moisture focused drought. So I think sometimes it's okay to disconnect from the drought monitor. Okay, there were important differences between topsoil and subsoil we're going to have to get into maybe for another day. And then I think one of the main takeaways I hope that we could show with this data is there some way that these data can help the US Drought Monitor authors converge? And so this gets into some of the research questions. How well does this product work from other drought case studies? So we need to be investigating these metrics across different regions of the US and different drought events. We're going to be leveraging the US Climate Reference Network for that. We also need to understand how these metrics compare to already established, well understood 30-year plus data sets like SPEI, EDI, and try to understand how the metric can converge and help support those additional products, what's happening in the soil. And I think we have to look at vegetation health. And I really like some of the graphics of the photos and understanding the greenness of the vegetation. I think that's going to be paramount. So with that, please check out our website. We have a QR code. If you think you want to explore some of these products for your network, part of the Upper Missouri River Basin Data Value Study is disseminating not just the information, but also the how-tos. So happy to help with that in any way. So come find me or Nathan, and we'll be happy to talk about it. Thank you.
Thinking about the At what depths and what geographic locations where do you see the soil moisture values drop on?
Yeah, so great question, Tyson. We saw it more for the topsoil layer because it just varies more. It has a larger range. I don't know if I've narrowed down to geographic specific regions, and that's something we could look at. But certain stations maybe correlate better with GNATSCO, with the soils it's in. And so you get a better estimation of wilting point fill capacity than perhaps others. And so I don't know if there's particular soil type of soil depths where the GNATSCO is a little bit different compared to what the soil is in. That's just a guess, but. No, did that trigger something else? Sorry.
The shallow doesn't make sense, and it might be more pronounced in those western parts where the ratio of water loss by evaporation becomes more important relative to the water loss by transpiration. And so, anyway, that might help to explain why we see some of that. But certainly can go below building point plants doesn't go to evaporation in the same way.
Yeah, thank you for that. And that's something I think hopefully we'll be able to explore with a more extensive network beyond the UMRV. So that's sampling those direct locations out west. So thank you.
Well, thank you very much.